most everyone that thinks about farmers or farming associate plowing with a farmer. Can you give us a little idea of what we call tillage practices more today than plowing? But can you give us some examples and let us know a little bit about tillage?
Sure. So the primary purpose for tillage is to create a viable seed bed so that a farmer can get a stand of the crop that they're planting established in that field. And the second purpose of tillage that we see is for weed control. We want to have a weed-free seed bed in order to plant into so that crop, as it is a small seedling, has full access to all the available nutrients and moisture that's held in that soil. And so using tillage methods to control some of the weeds is important to us in initial stand establishment. Through our modern agricultural practices and modern technology and chemicals that are available to us, we've started to see an increase in minimal till acres go in across the coastal bend area. Minimal tillage or reduced tillage is where producers plow less or till the soil to a lesser degree because they're reliant on some of the herbicides to provide that weed-free environment in that field for that crop rather than relying on additional tillage operations to keep that field weed-free. There are a lot of advantages to reduced tillage or to no tillage systems in that those types of systems will increase the amount of organic matter that's held on that soil surface. By increasing the amount of organic matter, we can reduce the amount of wind and water erosion that can occur on that field. It can also help increase the infiltration rate of rainfall whenever we do have a rainfall event on a field. So it allows for a reduced amount of moisture runoff and allows that producer to capture that moisture in that soil profile. Also, having an increased amount of tillage on that soil surface allows for an increased amount of nutrient holding capacity for that soil. So that soil is able to hold additional nutrients for that crop as it grows and develops. And then finally, when we have reduced and no tillage systems, we start to see improved soil structure in that soil as well. And that increase in improvement in soil structure allows for a better exchange of gases and our moisture. It allows for infiltration whenever we do have rainfall into that soil surface, and again reduces and helps with the amount of runoff that we lose whenever we have a rainfall event.
So when you talk about composition of soils, can you kind of briefly expand on that?
So a good composition for a soil is going to consist of about 45% mineral materials. We're also going to have anywhere from 15 to 20% air in the pore space between those minerals, and then we're going to have another 15 to 20% moisture or water within that mineral portion. And then that remaining 2 to 5% or so is going to be organic matter. And that organic matter could come in the form of decaying plant material. It could also come in the form of living microorganisms such as bacteria, fungi, protozoa, as well as some micropods such as earthworms, nematodes, and some of our arthropods such as fire ants and some of those types of things as well.
So again, Jason, thank you for being with us today and giving us some insight into the importance of soil, and appreciate your time and effort. And would you again reiterate the importance of soil?
Sure. So soils are a dynamic, ever-changing composition of minerals that provide support to plant growth, and also have a mixture of nutrients, gases, water, and microorganisms. And so they're vitally important to crop production and plant growth and development that we depend on to get our food and fiber. And I'd also like to remind everyone that, as we said in the beginning, our existence does rely on that 6-inch layer of topsoil.